Moving on to part 2 of 5-4. Got to finish up our notes from yesterday. Make sure our phones are away, in a pocket or in a bag. We're not on our phones. Solving radical equations. So someone remind me what we did yesterday. Like, explain it to me. What did I want to do first? Get what by itself? Not x. The radical. I wanted to get the radical by itself, correct? Once the radical is by itself, what can I do to both sides to get rid of the radical? Square both sides, that gets rid of the radical. And then I would try to get x by itself. Correct? A little refresher from yesterday. So let's continue these notes. We got to talk about these things called extraneous solutions. Squaring each side of an equation can sometimes introduce solutions that are not actually solutions of the original equations. These solutions are called extraneous solutions. So this is why we check our work, check our solutions. That's why you checked your solutions so many times yesterday. To make sure that those solutions actually work for our original equation. If you get a solution that doesn't work, we call it extraneous. Any questions about what an extraneous solution is? Am I good to go ahead and move on? Example 5. Solve x equals the square root of x plus 6. What's the first thing I need to do before I do anything else? Make sure the radical is by itself. Is the radical by itself right now? Yes, it is. Radical is by itself. Nothing's being added to the radical, subtracted from the radical, multiplied by the radical, or divided by it. So now that the radical is by itself, what can I do to both sides to get rid of the radical? Square both sides. Look at that. I added color. Squaring a radical will get rid of the radical. Questions on that first step? Okay, this one's a little different than the ones we saw yesterday. It's a quadratic instead of just the variable x. Anyone have any ideas what I need to do here?
Subtract x from x plus 6.
Subtract x from both sides. Can I subtract x squared and x?
Mm-hmm.
I can combine them?
No.
Yes.
Why not?
Because one's squared and the other one's not.
One's squared, the other's not. They're not like terms. So I have to write it as x squared minus x. Everyone good with that step? Okay, what's the next thing I need to do?
Divide by x.
Not quite.
Divide by x squared minus x.
Not quite. It's alright. It's alright that you're wrong. I like these ideas coming out. So anyone else have any other ideas?
We already say divide by -1.
We're not going to do that. No, not quite. Say what? What'd you say? Not exactly. I'm thinking about something with the 6. Subtract 6 from both sides. I'm going to get everything to the left-hand side. Does anyone see how that helps me?
Can we do the x puzzle?
Yep. I'm going to factor my quadratic. Got my 2 sets of parentheses. What's the variable I'm using? X and x. What are my 2 signs?
Minus and minus.
Not quite.
Plus and minus.
I got a plus and a minus. Fill out my t-chart. Someone give me 2 factors of negative 6. 1 and negative 6. What does 1 plus negative 6 give me? Negative 5. We want negative 1, so that's not it. Someone else give me 2 other factors. Negative 3 and 2. What's negative 3 plus 2? Negative 1. That's what we want, right? So I can stop there. So I get x plus what? 2. X minus 3. Everyone's still good with factoring. What do I do after I factor? Use my zero product property. Set each factor equal to 0. And now what do I do? Subtract 2 from both sides. I get x equals negative 2. Add 3 to both sides. We get x equals 3. Questions on that? So I'm saying negative 2 and 3 are possible solutions of my equation. Where do I go after I get my solutions? Plug them in. Plug it in, plug it in. You guys ever seen those commercials?
No.
I'll have to show you all the commercial too. I had to show 4th hour too. It's a good one. You know those scent things that you plug into the wall? No, it's not Scentsy. It's a Glade plug-in. No, it's a Glade plug-in. That's what the commercial comes from. Anyways, I'm plugging in my 2 solutions to my original equation. Which x do I plug into? Both of them. So let's plug negative 2 in first. And then I'm going to work down both sides of the equation. What's negative 2 plus 6? 4. Square root of 4?
2.
Does negative 2 equal 2? No, it does not. So what can I say about negative 2? Negative 2 is an extraneous solution. So it's not an actual solution of my original equation. On your assignment, I want you to tell me if something is an extraneous solution just like this. Everyone got that? Okay, now what do I need to do? Plug in 3. What's 3 plus 6? What's square root of 9? Does 3 equal 3? Yep. So x equals 3 is a solution of my original equation. Once again, this is why we check our solutions, to check to see if they actually work. If they don't work, they're an extraneous solution. Questions on example 5?
What was your answers?
Yep. I'd say x equals 3. That's a real solution. Negative 2 is an extraneous solution. We good there? Can I move on? All right. Example 6. Solve 13 plus square root of 5n equals 3. 13 plus the square root of 5n equals 3. Is my radical by itself? It is not. What would be my step to get it by itself? Subtract 13 from both sides. What's 3 minus 13? Negative 10. Is my square root now by itself? Yes, it is. So what can I do? Square both sides. So I get 5n. What is negative 10 squared? Positive 100. Negative 10 times negative 10 will give me positive. And then where can I go from here? Divide by 5 on both sides. N equals 20. So I only have one solution, one possible solution here. I'm saying it is n equals 20. What's my next step? Plug it in, plug it in. You guys are going to sing that every time you plug something in now. What is 5 times 20? 100. What's the square root of 100? And what is 13 plus 10? Does 23 equal 3?
No.
It does not. So what can we say about 20? 20 is an extraneous solution. Do I have any other solutions to check? No, so what would my answer be here? Not that. I need a... There we go. If all of your solutions are extraneous, then we have no solution, no actual solution to our equation. Is everyone good with that? Questions on example 6? Can I move on? Example 7. Word problem. Ooh. The period p in seconds of a pendulum is given by the function p equals 2 pi times the square root of L over 32, where L is the pendulum length in feet. A pendulum has a period of 4 seconds. Is this pendulum twice as long as a pendulum with a period of 2 seconds? Explain your reasoning. Any ideas how to go about this? Replace P with what? 2. Okay. Okay. And what would we do after that? Solve it. What would I do after that? Replace P with 4. What do I do with that? Solve it. And what do I do after I get both answers? Compare. Very good. So, we're going to be doing 2 problems here. We're going to replace P with 4 to see what the length, and solve for L, see what the length of that pendulum that has 4 periods is. Then I'm going to do the same thing with 2, plug that in for P, solve for L, see what the length of that pendulum is. Then we're going to compare the 2 lengths, see if one is twice as long as the other. Does that make sense? So it doesn't matter which one you start with. Since 4 came first, I'm going to plug 4 in for P. And we're going to solve for L. Is my radical by itself? No. What would be my first step to get the radical by itself? Bless you. By? Very good. Divide both sides by 2 pi. 4 divided by 2 would give me 2. I still have that pi in the denominator. Equals the square root of L over 32. Questions on that first step? Is my radical now by itself? It is. So what can I do to both sides? Square both sides. If I'm squaring a fraction, what do I do? Not KFC, nope. Distribute it to the numerator and to the denominator. So I just raise the numerator to that power, the denominator to that power as well. So what's 2 squared?
4.
And then pi squared, I'm just going to write as pi squared. So I get 4 over pi squared equals L over 32. We're almost there. How would I get L by itself? Multiply by 32 on both sides. So 32 times 4 would give me 128 over pi squared, which is approximately, if I type this in my calculator, 12.97 feet. So the pendulum that has a period of 4 seconds is approximately 12.97 feet long. Everyone good with that? So I'm going to write that up here. Can I erase all my work here down at the bottom? Because now I need to find the pendulum length of a pendulum that has a period of 2 seconds. So like we said earlier, what are we replacing with what? Replacing P with 2. And once again, solving for L. Is everyone okay with that? So it's essentially the same steps, we just have 2 instead of 4. So what was my first step?
Divide by 2 pi.
Divide both sides by 2 pi. 2 divided by 2. So I get 1 over pi equals the square root of L over 32. And then I square both sides to get rid of that radical. What's 1 squared? So 1 over pi squared equals L over 32. And how would I get L by itself now? Multiply by 32 on both sides. So what's 32 times 1? So I get 32 over pi squared, which is approximately 3.24 feet. Everyone okay with both of my answers? Did I answer the question yet, though? No, what's the question asking? It's asking if the pendulum that has a period of 4 seconds is twice as long as a pendulum with a period of 2 seconds. Is that the case? Very good. It's actually 4 times as long. If I multiply 32 over pi squared times 4, I get 128 over pi squared. So I'd say no. It is actually 4 times longer. Questions on example 7? Not too terrible, right? There's a lot of work, but not too terrible work. Any questions? Can I move on? There we go. Page 269, numbers 45 through 63 all. This will be due on Monday, April 26th on Canvas. Any questions, comments, concerns about the assignment? Does anyone have any questions before I end my recording?